Remember, one philosophy of the stellar is just like the water tank you saw in the simulation I gave to you, or like the cup down to the water stream. Unless you drain the water only accumulating. So whenever you build the pipe, you always have to build the two, one input, one output, and the direction matter. The conceptual model for the year 1, how they die. 85% died itself. 15% goes to the second year. That's how you do it. And how do you reproduce? And the 1 from the third year, X, 5, 4. And the 2 from the, 5 from the second year, F stands for fecundity. That's how you look at the first year population. The second year population, you look. First, let's see how they die off. 50% died, and the 50% goes to the third year. And how they reproduce? They only got the 15% from the first year. That's how they reproduce, right? They come from the first year. For the third year, you look at the conceptual model. 100% all died. That's it. That's your model. No, that's a conceptual model without many numbers. Now I build up the real mathematics model. I have the exercise for you to play and to see if we get exactly the same result as we had in the first module. Well, we add a lot of things, but those are the information. I make it this just to let you change it. I don't put the fecundity rate about 5x, 4x. How about you do another research that have 50x and 40x? Then you can just, in the interface, slide the bar to change your birth rate. And then the model going to rerun and find the new number. That's how you do the sensitivity analysis very quickly. You don't need to rebuild the model. All you need is change those numbers. Change those numbers. Change the survival rate. Whatever changeable, you change it. Now those with a little bar means you can always change. What other information are so important? I made it a little complicated. Oh yeah, this one, we already talked about 4, that's F2, and F1, no actually F3, and what's the P1, P2? Okay, here you go. This one is the P1, the survival from the first year to the second year. And this is the P2, the survival from the second year to the third year. That's all you see from the Lesson matrix. Then why I have something else? Well, look, I said that the Lesson matrix did not think about the mortality. We have to think about it. Without this mortality, your dead body will accumulate. They all counted as a population. That's not right. So I have the 3 death rate here for the old model. 85% is died here, and 50% died here, 100% died here. So you have to include that. That's a pitfall for your modeling. The other thing you don't have to have. The total population, that's for just monitor your sensitivity analysis. And then we look at the percentage of the first, the percentage of the second, and the percentage of the third. That's what we do, and find the eigenvalue and the eigenvector. You remember? This number, once it's stabilized, that's the eigenvector. And what's the eigenvalue? I'll let you remember that. If you don't remember the eigenvalue, you really did not understand the population model. Now you got it. The eigenvalue is this RT, this R is the eigenvalue, or e to the R is the eigenvalue. That's what you see. Anyway, we go to the mathematics model. Very simple. See, what do we have? The population of the first stage equals a moment ago. This moment could be a year, could be anything you choose, minus the fecundity of the third year, that's the 5 egg, 4 egg, the fecundity of the second year, minus the transition, change to the first, the second year, and the minus the mortality, the death rate. Okay, second year, exactly the same, see? Exactly the same. The third year, and then you put all the numbers. I'm not going to go to that detail. Well, look at the third year. The third year don't have any income, only die. The population of third year equal the population before times the population come from the second year and times the 100% death rate of the previous year. Well, what is the input? The input, you have all the mortalities and the fecundities, and what the P stand for progress. Progress. P1, P2, and the output, that's when we get the eigenvector, and the percent of first year, percent of second year, percent of the third year. If you still remember, I still remember, it's 80% here, and 13% here, 7% stabilized. Well, then you think, oh, it really depends how do you look at the problem. You can use algebra to solve the problem, to look as a time sequence, or we can say time series. But we can also use the differential equation to talk about a continuous model. And in stellar, nothing's real continuous. The continuous model is discretized. And then you solve it like a difference equation. Well, we're almost to the end. Then you say, oh, I don't remember all those details. I don't know what you're talking about at all. Please go to read the lecture notes and go to do the exercise. That's when you really get the detail. In my lecture here, I want you to see how we step by step to improve the model, make it more realistic, and identify the insight, and then also know the limit of our model. And then we also give a little bit of preview about the power of stellar and the simplicity of the philosophy. It's just like the water flow from the pipe, and from the pipe to the switch to the cup, and then the control is all about information, which see if the cup is full, and then you watch it, and then the information from your brain to your hand, you turn it off, and then realize a feedback system. We use the information to control the flow of the material. And keep that in mind, you will be very natural, understand how to build a stellar model. If you read all those mathematics equations, you say, of course, that's always the case. What you have equal what you had plus the change. Oh, what is change? Change in mathematics, we use derivative to talk about a change rate. So everything should connect, will be connected. if you just do the work. And you push to the threshold, you're going to suddenly understand everything. You say, oh, no wonder, that's a model. A model is not about right or wrong. It's about if give you some insightful information or give you nothing. All right, thank you for your participation. I'll see you next time. We're going to look at more complicated models, but again, not focus on the detail, but about the idea to build the conceptual model and how do we analyze the concern, the problem. See you next time. Thank you again.